Hello everybody, I'm a weather nerd, and this is my preliminary winter outlook. Like isn't a strong word, so if you think I've cleared that bar by the end of the video, please give my video a like. It helps the video spread through the algorithms. Also, if you would like to know when I make an update to this winter outlook, or if you are interested in weather and how it works, I'll be making videos for that, so you should subscribe. Now that that's out of the way, we can get into my outlook. For this winter, I use the state of the ENSO, which is an acronym for the El Niño Southern Oscillation, the PDO, or the Pacific Decadal Oscillation, the AMO, or the Atlantic Multidecadal Oscillation, the QBO, or the Quasi-Biennial Oscillation, and the number of sunspots on the sun. I used all of these factors to come up with analogs, and to make my own prediction. I am planning on making a video about each of these features, and I don't want to take up too much time in this video, so I'll give you a crash course on all of them. Let's first talk about the El Niño Southern Oscillation. The El Niño Southern Oscillation is the temperature anomaly, or the difference between the actual temperature and the average temperature of the surface of the ocean on the equator between South America and Indonesia. There are 4 regions where the temperatures are measured. But for this, we want to pay attention mostly to the regions of ENSO 1 and 2 and ENSO 3.4. If the ENSO 3.4 region has temperatures more than a half a degree above normal on average for more than a few months, then there is an El Niño. Conversely, if the ENSO 3.4 temperatures are more than a half a degree below normal on average for a few months, then there is a La Niña. For an El Niño, if the ENSO 3.4 area is warmer than the ENSO 1 and 2 region, it is called a Central Pacific or Modoki El Niño. And if the ENSO 1 and 2 region is warmer, it is called an Eastern Pacific El Niño. Next, I'll talk about the PDO, or the Pacific Decadal Oscillation. The PDO is the pattern of the anomalies of temperatures in the Pacific. If there are warm anomalies on the coast of North America and extending towards the equator, and cold anomalies in the center of the warm anomalies, there is a positive PDO. And if the anomalies are switched, with the cold anomalies next to the coast of North America and warm anomalies in the center, there is a negative PDO. The AMO is the Atlantic Multidecadal Oscillation, and it measures the temperature anomaly of the North Atlantic, or the Atlantic north of the equator. The QBO is the Quasi-Biennial Oscillation, which measures if the winds in the stratosphere above the equator are going easterly or westerly. And the amount of sunspots is a cycle that happens every 11 years, where at the top of the cycle are the most sunspots and when the sun is most active, and at the bottom of the cycle is when the sunspots are at their lowest numbers and the sun is the least active. This year, I am expecting a weak to moderate Central Pacific El Niño, though it is still debatable if it will be a Central Pacific or an Eastern Pacific-based El Niño. The ENSO affects the world's weather by changing the place where thunderstorms develop. In Eastern Pacific El Niños, thunderstorms develop near the coast of South America more often than usual. And in Central Pacific El Niños, thunderstorms develop in the middle of the ocean more often. Central Pacific El Niños have a tendency to cause a pattern which often has a high pressure in the western portion of the United States. For the PDO, I am expecting it to be in the positive phase. One weird thing I have noticed, just going a bit off the tracks here, is even though the Pacific looks like it's in a positive-ish PDO, the value that NOAA gives the PDO right now is negative. So this is the area that I'm least confident about. Even though I'm predicting a positive PDO, I'm not sure if it will be in the end. Positive PDOs help develop high pressures form on the west coast of North America because of the warm water beneath them. For the AMO, I am expecting it to be in the warm phase like it has been since around 1995, but not as warm as some of the years in between then and now. Depending on where the warm waters are, you can forecast general tendencies of the winter. For the QBO, I'm expecting it to be in the positive phase, which usually means a stronger polar vortex that doesn't let cold out as easily, but I am also expecting a low amount of sunspots, which have the opposite effect. Here's the spreadsheet that I used to help me find the analogs for this winter. You can see on the left side all of the equations that I wrote, and all of the colors so the computer can spit out a few analogs. And on the right are my grades for the ENSO, PDO, and AMO to see what looked most similar to what I expect this year. Here are the analogs that I came up for this year. Now, I'm going to show you what the analogs were like. Just remember, for temperatures, that the climate averages were up to a degree cooler than what they are now, so below normal temperatures in the analogs might just be normal if they were to happen today. I used the analogs for the winter as a whole and for the specific months. So for the analogs from December through March, they have the average temperatures being cooler than normal in the east, basically east of the Rocky Mountains, with the coolest temperatures in the southeast, and they have the warmest temperatures in the Pacific Northwest. So here is December, and it shows very warm temperatures in the Northwest and just in the West in general. The warmest temperatures, again, are in the Northwest and the northern Great Plains. The analogs also have cooler than normal temperatures in the southeast and up the east coast. In January, the analogs have the coolest temperatures from the Great Plains east to the east coast, and the warmest temperatures in Maine and the central west. It has the core, I guess, of the coolest temperatures in the Great Plains specifically, and in the southeast. Now, February in the analogs is the coolest month, with everywhere east of the Rocky Mountains being cooler than normal, with the core of the coolest air being in the Ohio River Valley. And it also has warm temperatures in the Mountain West in general, with the core of it, I guess, in Oregon, Washington area. Now for March, the analogs are a little weird, and they have the whole United States cooler than normal. I think it's because it has some years where it's cooler in the west than normal, and some years where it's cooler in the east than normal. But it has the coolest air centered in Kansas. It also might have a trough in the center of the United States right over the Great Plains, which would make it the coolest area. Now for the winter as a whole, the precipitation is looking to be above average on the Gulf Coast and in the southeast, up the seaboard a little bit. It also has drier than normal conditions in the Great Lakes area in the Midwest, as well as the southern plains into northern Louisiana, Mississippi, and Alabama. This kind of looks like a mishmash of many different maps, and that's because it is. So here is what the specific months look like. The analogs show wetter than normal conditions from Northern California up to Washington, and Washington is the wettest area in the United States in this analog map. It also has southern Florida as wetter than normal. In January, there are wetter than normal conditions all up and down the East Coast, but drier than normal conditions in the South Mississippi River area. Also, there are wetter than normal conditions from California up to Oregon and some of eastern Washington as well. For February, the conditions are drier than normal in the New England area, as well as the Midwest, and just in general, the South Plains over to western North Carolina. They also have drier than normal conditions in the Pacific Northwest and Northern California, but wetter than normal conditions in Southern California and small parts of Louisiana and Florida. In March, the areas that are wetter than normal are the Southeast and California area, with drier than normal areas in eastern Texas and the western Midwest area. Now, based on where the warm water is in the Pacific, along with the El Niño, I think that we are likely to have high pressures in the west part of North America more often than usual this winter. One thing I think might happen is the high pressure being further north than usual, and the southwest getting more precipitation than usual through the southern jet stream. Since there is an El Niño and the solar radiation is lower than usual, I expect a negative NAO and a negative AO, which help release the cold from the North Pole area. The few things that could put pause in this is the positive cubia that I am expecting, and the temperatures of the water around Greenland. Specifically, the waters around Greenland may make it less likely that negative NAO forms more often than usual. Another thing is that I expect the sea surface temperatures off the east coast of the United States to keep it warmer than it would otherwise be in the month of December. As you'll see in my maps, I think February is going to be the coldest month of the winter, because El Niño's coldest month is usually February. Now moving on to the winter outlook. Just a warning, take this with a grain of salt, because I don't have many of the skills necessary to predict the flavor of a season with much confidence or accuracy. I will make a video in the spring that will dissect my outlook and see where I got it wrong. Also, I'm more confident on temperatures than I am on precipitation, which is why I didn't go much below normal or much above normal with the precipitation. You'll see that in my actual winter outlook. So, for the whole winter, I expect the west coast, basically Arizona and Utah west, and parts of Wyoming and Montana west to be warmer than usual. I also expect Maine to be just normal compared to usual throughout the year, and I'll get to why that is in a minute. Also, I think that areas basically from the Rockies east will be cooler than normal, again, with the exception of Maine, and I think the coolest air throughout the 4 months will be in the southeast and the Ohio River Valley. For December, I expect it to be cooler than normal in the Florida, southern Georgia area, so I think the Pacific Northwest and the northern Great Plains are going to be much warmer than usual, with basically anywhere to the northwest of a line between southern Texas and Toledo, Ohio to be warmer than normal, with everywhere else having equal chances of being warmer or cooler than normal. For January, I expect it to be warmer than normal on the west coast, basically Arizona, Utah, Idaho, west. And I expect Maine and northern New Hampshire and Vermont to be warmer than normal. I think specifically Maine to be warmer than normal because I think that the negative NAO will be strongest in this month, and we also saw that in the analogs that it was warm during January. So that also shows what the rest of the country will be like, which shows from to the east of the Rockies and to the south and west of the Great Lakes region will be cooler than normal, with the core of the cold being in the northern Great Plains as well as the southeast. As I said, I think February will be the coolest month for the east, so I think almost anywhere east of the Rockies are going to be cooler than normal, and it's going to be much cooler than normal from the east of the Mississippi to Maine area, which I think will only be slightly below normal. And I think the core of the cold will be in the Ohio Valley region. Also in the west, I think it'll be warmer than normal because of the positive PNA, or the high pressure in the region, which will help with setting up the cold in the east. That's also partially what happens in January. In March, I think it's going to warm up a little in the east, with warmer than normal temperatures along the east coast, except for Maine. And I think that there's going to be a trough in the center of the country, which will mean cooler than normal temperatures, basically anywhere to the east of the west coast and to the west of the Mississippi in general. And the coolest air, I think, will probably be in the northern Great Plains. Now moving forward into precipitation, I expect the southwest to be wetter than normal in general. And I think the southeast will also be wetter than normal in general, with the drier than normal conditions in the Ohio and Mississippi River valleys, except for the snow belts, because I think that there will be higher than normal lake effect snow this year, especially since the lake temperatures in the Great Lakes are much warmer than normal at this time of year. Now let's break it down into the different months. For December, I expect it to be wetter than normal in Florida and the Pacific Northwest, but drier than normal in most of the rest of the Southeast. For January, I expect it to be the wettest month of them all in the east, with areas from Louisiana all the way up to southern Maine being wetter than normal. And I also expect the southwest to be wetter than normal. I expect the Pacific Northwest to be drier than normal. In February, I think that the precipitation in the east backs off just slightly. I still think it's going to be wetter than normal from eastern Florida all the way up to around the New Jersey area. And I also think that the southwest with California and southern Arizona are going to be wetter than normal. But I think that it'll be drier than normal in the Ohio Valley. And I think it's going to be much drier than normal, which is why I think overall for the year, this area is drier than normal. I also think that the Pacific Northwest is going to be drier than normal. And I think that for both January and February, the reason that the Pacific Northwest is drier than normal is because the positive PNA will have ridging over them, while the Southwest in both of those months will have the southern jet coming through, which will help keep them getting rain. And that's also why the East Coast gets rain both of those months. So in March, with the trough moving to the west, I expect a pretty large area to be wetter than normal, because I think the southeast ridge is going to slightly pump up the moisture in the region from Texas to Michigan. But I think the trough is going to stop precipitation for areas from the northern plains and northern Rockies. I also expect there to be wetter than normal conditions on the west coast. Thank you for watching. Just a reminder, if you think that I cleared the bar for a like, please do that. And also, if you want to see more of this, please subscribe. Have a good day.